All right, so guys, we saw the law of sines. Law of cosines we're going to use in two different scenarios that I will outline for you in just a moment. But first thing, remember, keep in mind we've got a triangle that is not a right triangle. So we've got easier methods if it is a right triangle. This we can still measure with A, B, and C. We've got our little side lengths here. So here is the law of cosines. Looks like this. If you're trying to find your little sides, A squared, it's equal to B squared plus C squared minus 2BC times the cosine of A. So it seems like a crazy formula. We actually have another formula for all of the other angles. They're pretty easy to memorize though once you see how similar they are to each other. So depending on what pieces you have and what pieces you're missing, it's going to make more sense to use one of these formulas over the other. So you'll see once we actually get going. So notice whatever side here, you have the other two sides squared and added together right here, all minus, and then you have 2 times the other two sides right here, and then the cosine of this angle. So the pattern is really, really similar each time. So we got these. We're going to reference them back in all the problems that we are working on here. So here's when you use the law of sines. We've got two different scenarios, and they're different from the times when you would want to use the law of sines, because otherwise we wouldn't need two different rules if they weren't applicable in two different scenarios. So we use law of sines in the SAS case. That is when you have two sides and the included angle. Or in other words, the angle that's in between those two sides. And then we can also use it in the side, side, side case. That is if we have, of course, all three sides. Okay, so I'm going to give you guys an example of each. Here's the side angle side case. So we've got two sides, and then the angle in between them would be angle H. So in this scenario, we are going to use, first of all, we're going to find our third side. So you're going to first use the law of cosines to find the third side. Okay, so we are going to use this. We want little h, so little h squared equals f squared plus g squared minus 2fg times the cosine of h. So it's just using those formulas we have on the previous page and just kind of adjusting them based on the variables that we have. So plug everything in equals. We've got 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of h, which is 73 degrees. So basically, just this whole thing is going to get plugged into your calculator, and that should be pretty easy. All right, so we plug 7 squared plus 10 squared minus 2 times 7 times 10 times, oops, that's a 1, times the cosine of 73. So we get this, 108.068. So remember, what was originally on this side was an h squared. So in order to get h, we're going to square root both sides. All right, so we get h equals. So on here, we can type in that square root button. And then let's just arrow up and paste that number in so we get a super exact answer. So we get about 10.4. H equals 10.4. So that's our first missing piece. So now we know all the sides. So we've got all three of the sides. We only have one of the angles. So our first step was to use the law of cosines to find the third side. Our next step is to use the law of sines to find one of the missing angles. And it doesn't really matter which one. We're going to use the law of sines to find one of the missing angles. So we can find, let's find G first. So we've got sine of G, which we don't know, over little g, equals the sine of H over little h, which is what we just found. Okay, so in order to get capital G by itself, we're going to start by multiplying both sides by 10. So this is basically just yesterday's stuff that we were doing with law of sines. So let's plug this whole side into the calculator. So we've got the sine of 73 degrees over 10.4 and then times 10. So we get this value right here, about 0.919. Okay, so what we do is we're going to take the sine inverse of this value right here in order to get G by itself. So let's plug this into the calculator. So press that sine inverse key, and then I'm just going to paste this value right in. So I get this, about 66.9. Okay, so we check, make sure there's room for both of these angles. There is. Check to see if there's room for the other angle, because remember, law of sines, we always have a possibility of having two. 113 and 73. No, those are not going to fit in the same triangle, so we only have one possibility for G, which is good, saves us a little work. And then finally, we find the last angle. Last angle is super, super easy to find. We just subtract them from 180. So our last angle is F. We just start with 180. We subtract away H. Subtract away G, and then that will leave us with F. So we've got 180 minus 73 minus 66.9. So that leaves us 40.1 for F. Okay, so that is the side angle side case. That's what we do for that. In the side case, so if we have all three of the sides, all right, this is something that is super, super important. We have to find them in decreasing order. Okay, so in the side case, you must find the angles in decreasing order. So that's super important, otherwise it could throw you all off. So make sure you start with the one that you know is going to be the biggest, then the medium one, then the small one. All right, so if we look at the sides, side C is the biggest, which means angle C is going to be the biggest. So we use the formula that brings us back to angle C, which would be C squared equals A squared plus B squared minus 2AB times the cosine of C. So we're going to use that formula. So we're going to plug in these three values into little a, little b, and little c, and then we'll just be able to solve for cosine C. So this is a little bit more complicated to use this when we're solving for angles, but I'll show you how to do it. So we've got C squared equals A squared plus B squared minus 2 times A times B times the cosine of C. All right, so here's something that's super, super important. See, we've got addition, we have addition, subtraction, and then this is all multiplication. Think order of operations. Multiplication comes after addition and subtraction. So a lot of people try to just combine like all of this up. You cannot do that. This is all attached because of the order of operations. So we're going to simplify everything up as much as we can. So we've got 144, that's 12 squared, and then 9 squared plus 7 squared is 130 minus, and then 2 times 9 times 7 is 126 times the cosine of C. So again, you cannot subtract those values because multiplication trumps the subtraction that we have. So make sure this all stays together. So what you can do is you can subtract this 130 from the other side, and we're going to do it like that. So this ends up being 14 equals negative 126 times the cosine of C. And then we divide by this negative 126. We can figure out what our value is. So this will cancel out. So I take the cosine inverse of whatever this value turns out to be, and then I'll have my value for C. Okay, so let's plug that in. So cosine inverse of whatever this is gives me my angle. So I get about 96.4 degrees. Okay, so it's not ideal to find an angle using the law of cosines. It's pretty tricky. So we want to do law of sines next, for sure. So to find the next ones, next go to the medium one. The medium one would be A. So now we're going to use the law of sines. It's a little bit easier to use. So sine of capital A, which is what we're trying to find, over little a, is equal to the sine of capital C, which is what we just found, over little c. Okay, so now we're trying to figure out what little a is. So we're going to multiply both sides by 9, cancel this out. So we'll have sine of a equals, and I'm just going to plug this whole right-hand side into my calculator. So fraction, I've got the sine of 96.4, divide that by 12, and then multiply the whole thing by 9. So I get this. It's 0.745. So then we know in order to get the angle, we do the sine inverse thing. Okay, so I'm going to hit my sine inverse key and then just paste that value right into it. So 48.2 would be my angle. Okay, and we always double check with the law of sines to make sure there isn't anything else that could fit in there. So if we do 180 minus this value right here, we've got 131. That's not fitting in with this 96-degree angle. That would be over 180 degrees. So we just have one possibility here. And then angle B is the easiest one to find. We know that they all add up to 180. So we're just going to subtract A and then subtract C, and that will leave us with angle B. So subtract A, subtract C, and that leaves us with our smallest angle. Okay, so we were missing all three of these angles and we found them. I want to give you here kind of a method to figure out how you would figure out where to start, whether you're starting with the law of cosines or law of sines. Law of sines is a little bit easier, so you always want to use it whenever it's a possibility for you. So here's a little setup here. So if you're given whatever these are over here, start by using this. So if you're given two angles in any of the sides, okay, so two angles in any side, I guess we should say side, you want to begin by using the law of sines. Okay, if you have two sides and an angle opposite one of them, that would also be the law of sines. So these are the two scenarios that I gave you guys in the previous video from 12.4. This is when you'd use the law of sines. And then these are the two scenarios that I gave you guys today. Two sides and their included angle, so that would be side, angle, side. This is where you'd start with the law of cosines. And then if you had all three sides, like we just went over, you would use the law of cosines as well. All right, so we're going to stop right there.